Hello everyone. In this video I'd like to show what I've learned trying to deconstruct container networking in Kubernetes. I originally played with Flannel and Calico setup, also called Canal, but decided to start with overview of container networking and Flannel particularly. I will start with explaining some container network theory and then show how this corresponds to what you can actually find on your Kubernetes cluster. So why we need a container network at all? So if we look on our PC and how the Docker engine is working on your laptop, for example, it's pretty simplified because you can always spread the network over your containers on the particular machine, even on the layer 2 network, because everything can be connected to some virtual interface and all the containers will then be able to connect to each other. The thing complicates a little bit when we start talking about more than one machine or more than one node. So we then have two nodes, both are running Docker engine and both have their own containers trying to connect to each other over the network. And now Kubernetes has three goals of the container networking, and those are that pods can communicate directly with all other pods without any masquerade on their IPs. Also, all the node agents, so some services on the node, can communicate with all the pods. And the IP that container sees itself, so the one that he sees from the inside of the container process, is the same IP that others see. And there are many ways to implement this approach. VLANs is one of the examples, so that we can just spread this layer 2 network over all the nodes. But this is literally making the layer 2 over those different connections between nodes. It has its own problems, especially when this layer 2 domain grows. So there is a successor of VLAN, which is called VXLAN, which implements a bit different approach. Final goal is that we have spread the layer 2 over a couple of machines, but the transport of layer 2 packets is done by encapsulating it with UDP packets sent over layer 3 network that is spread over those nodes. And this layer 3 network can be same cluster or even internet, right? So everything that has IP can be used here to spread this layer 2 network over different sides of this channel. VXLAN has also concept of overlay network. So this is the network that is laid over different nodes, connecting all the endpoints in layer 2 network. And then there is also underlay network, which is the underlying physical network consisting of both layer 2 and layer 3 equipment that implements this spreaded network. And this overlay network is exactly what was needed also for containers. That's why the term overlay networking, container networking is also there. And it happens that VXLAN is perfect solution for it. And it happens that VXLAN is also the recommended backend for Flannel, which is exactly how Flannel makes all the pods and containers connected. So it's spreading the big network over a whole cluster and assigning sub networks of this network to the particular nodes. And then the CNI plugin is attaching IPs to pods, and within a pod, all the containers see themselves as localhost. So IPs are only assigned per pod, not per container. And this is how all the containers fulfill those requirements that they can see each other with like fixed IP. All the node services can also reach them with some proper routing, and the IPs that are seen by the pods are the same that they are called from different pods. Okay, so that's about theory. Let's check out how it looks like in practice. I will start with my own PC and Docker engine on it and just show how the concept evolved moving to the Kubernetes cluster. So I already started one container with Nginx. It's running here. It's exposed over 8080 port. And if we now see what are the interfaces on my laptop, we should see a couple interesting things here. So first of all, there is Docker 0 interface. which turns out to be a Linux bridge. And this works pretty the same as a physical bridge. So it has interfaces, and everything that comes on one interface is passed to all the other interfaces. So this is the same you might use when playing some games in the old times. You were just connecting different pieces to one bridge, and you basically created very primitive LAN. And then there is also that interface, so virtual Ethernet interface. It seems that it has a master Docker 0, so this is the interface, one of the interfaces of Docker 0 bridge. And that's also always have two ends. So we see now one of the ends, and we need to find out where is the other one. So first of all, we need to check out what are the network namespaces on my machine. And if we try to do it like this, nothing will be showed. And this is because Docker is not creating proper symlinks for the network namespaces. But this can be easily fixed. So let's first, once again, list our container and set the container ID variable. Then we need to get the process ID of the container. So let's do it like this. And now I will just create a symbolic link between the process network and place it in the network namespaces directory. So this is where the IP netns is reading the namespaces from. I need to do it with root. And now we should be able to see the namespace here. So network namespaces is just another or one of ways that Linux allows to isolate workloads on the system. And Docker just took all those functionalities and turned it to the one solution. So we have this isolation of file system, like dividing CPU power and so on. So all those things allows to run your containers isolated from others. And network namespaces is just one phase of it. And if we now have a network namespace, we can execute some commands within it. So if we now copy the name of the namespace, and we can try to exec something from the namespace, like, for example, list the interfaces. Yeah, so this is exactly what is shown from this namespace. And now, as you can imagine, this namespace is our containers namespace. So if we try to do something a little different, so for example, this one, and try to go into the container itself, we can now try to view the IP that container sees from its side. And as you can see, it's the same that is defined on the interface in the namespace we just checked. So the whole connection goes like this. So there is a process in the container. In our case, it's the Nginx. So all the traffic goes via ETH0 interface, and it happens that it's the virtual Ethernet tunnel. So on the other side, there is the bridge interface, and from bridge it goes via routing tables on the host. So we can now check, just clear up. We can once again check what is the routing, and as you can see, all the traffic from the container network will go to the bridge, and other than that, it will be passed as any other traffic from the processes on my laptop. It's also worth checking the routing table, because Docker also adds some entries there. So if we view the NOT tables, once again. Okay, so we have a couple of interesting things there. First of all, there is this Docker chain that is used twice, and there is definition here. So first of all, if we have any traffic incoming, then this Docker chain will be executed, and if it's not from Docker zero breach, it will be passed to the container and the port. So this is exactly how this works if you try to access the Nginx from your browser, for example. So it will be forwarded to the container port, and another one pretty the same for the output chain. So this chain is executed whenever any process on my laptop would try to reach the container or the Docker, then it will be also go through this chain, and it will be forwarded destination NAT so that it reaches the Docker container. And then there is the part with masquerade, so source nothing. So whenever traffic goes out of Docker, it will get the source nothing. So it will get some artificial IP going out from my laptop. Okay, so let's now move to the actual Kubernetes cluster. I will connect to one of the worker nodes and see how it looks like there. So once again, we can view the interfaces, and this time we have a little bit more complicated situation here. So again, we have a Docker zero breach, but it's down, so it's not used, although we have the containers running on this node. And then we have a flannel 1 interface, which turns out to be a VXLAN with ID 1. So Linux kernel has already support for VXLAN, and you can just create special type of interface that is just transparently implementing this VXLAN solution. And then we have the CNI 0 breach that is up, and a bunch of virtual Ethernet interfaces similar as we had on my laptop. And it works pretty the same, with the small change that the Docker 0 breach is not used, but CNI 0 is the main breach that is doing similar job as the Docker 0. So we have the 4 virtual Ethernet interfaces connected there on one end. On the other, it will be exactly the same as on my laptop. There will be container processes there. So everything goes through the CNI 0 breach. And then there is a routing table. And as you can see, everything that goes to particular subnet is going to the CNI 0 bridge, so to all the pods and containers behind the bridge. And other than that, everything from the other subnets, which are representing subnets on other nodes, will go via flannel.1 interface. So this is very simple routing that is allowing to connect all the pods from different nodes and from different flannel subnets. Now, if we would like to get some more details about flannel itself, we can easily find out the flannel container. In my case, my cluster was deployed using RKE, so I will find it somewhere here. So this is the one, and we can docker exec into it and try to view some configuration like flannel config. And this is exactly the parameters the flannel is using. So we have defined subnet for this particular worker and this overlay network that is spread across the the workers is here. And that's basically it about how it works. There's of course a lot of things going on IP tables part, but it's rather complicated, so I don't want to show it. But in general, it's doing pretty similar things. But there will be also entries from kubelet that, for example, is implementing services. So this forwarding of packets between service and pods. So those entries also will be in the IP tables. But other than that, it works pretty similar as it was defined on my laptop.